Have you ever had things break in production and you're not quite sure what went wrong? I remember the good old days when you had to go use things like tail and grep and then randomly click around the app to try and figure out what broke. You don't have to do that anymore, thank heaven. All you have to do is go sign up for AirBrake and then install it in your app. AirBrake is really simple. You get a little code that you put into your config file, and then you just install the gem. That's it. Really simple to set up. Then what it does is it aggregates all of the exceptions and errors that are thrown by your application so that you don't have to keep track of that anymore. It collects other information from the system as the errors occur, so parameters and things like that, depending on where the error occurs. And one thing that drove me crazy when we first started getting apps like AirBrake doing this work is that you would get 10,000 of the same error, and that doesn't happen anymore. Now they just aggregate it all together. You can go look at the individual errors and see where and what actually happened, but when it comes right down to it, they just let you know, hey, this error occurred 10,000 times, and then you go look at the individual ones so you can get them fixed. It's really easy to install. I already said that, but I just can't stress that enough. You take 2 seconds, you get it installed, and then you're off to the races. When I'm running a business, that time that it saves me is huge. So go check them out at airbrake.io/rubyrogues, and that'll let them know that we sent you. But seriously, just make your life easier. If you go check it out at airbrake.io/rubyrogues, you'll get AirBrake free for 30 days, plus get 50% off the first 3 months on the startup plan. So go check them out. You can thank me later.
Welcome, everyone, to Ruby Rogues. Today we have Eric Berry. Hey! And Dave Kimura.
Hey, everyone.
And our special guest today is Takashi Kokubun.
Hello, nice to meet you.
And my name is David Richards. And today we're really excited to talk about Ruby 3.0 and some of the speed improvements that Takashi's been working on and other improvements to look forward to. So first off, let's just start with a quick introduction. Takashi, could you tell us just a basic background of some of the things you're working on?
Okay. I'm a Ruby committer since the last year, and I'm a maintainer of the ELB, a template engine, default template engine of Ruby, and I'm also working on some template and other template engine implementations like Haml and Hamlit. It's another implementation Haml language, and also I'm employee of Treasure Data, which is some big data company, and I'm working mainly as a layers application engineer. So I'm improving the Ruby's performance mainly for layers application. And currently, I'm working on the JIT Compiler that is implemented under development in the Ruby 2.6. So hopefully, you'll be able to use that in the next Christmas.
Nice. We'll look forward to that.
The big question I had. The big question is, will Ruby 3 be released this year? And obviously, the answer is no.
Yeah.
So for those who don't know what the JIT compiler is, can you go into what it is, how it can be used, and if people are just going to benefit from it by default, or if they will have to do something in order to really take advantage of it?
Current JIT compiler implementation in Ruby 2.6 is that method JIT compiler, and the characteristics of it is that it's only available for method. So if you run a short running script or some plain script, you would not be able to gain a benefit from JIT compiler. So you should create a method, and you should call the method many times. At least you need to call the method 5 times by default to invoke the JIT compiling. And also, you need to pass the -- JIT option to Ruby binary to use JIT compiler. So it's not available by default. And it has some problems in performance, even though it's for performance improvement. It has some performance regression while the JIT compilation is going on. So, for example, in Rails application, as it has many methods to be compiled, with JIT enabled, Rails application becomes a little slower during the comparison is going on. So it's a lot. There are a lot of things to work on, but in some micro benchmarks, JIT compiler is able to improve the Ruby's performance by 6 times faster or 3 times faster in depending on the benchmark. So it's potentially can improve the performance much better in some benchmarks, but we need to make many improvements in that to gain real world application gain many improvements in the real world applications.
Yeah. And, I think benchmarks are always nice and great, but the real world application, that's where it boils down to. That's what we want to see the performance increase. So, and, when I say the real world application performance, I'm excluding the boot time for a Rails application or something like that, because once the application is booted, who cares how long it took to boot if we are already, running with the application.
Mm-hmm.
So in the example that you gave with the JIT compiler having to load up and compile a lot of these, thousands of Rails methods, once that's done, have you guys done any kind of benchmarks to see if the actual application performance is increased?
I actually benchmarked the performance after the all JIT compilation is done, but currently it is not so improved, or rather it becomes a little slower. But so probably it needs method inlining. It's kind of optimization by JIT compiler, because there are many methods in Rails or Rails application would have many splitted methods that can't be easily optimized by compiler. So I understand we definitely need method inlining to gain the best performance of Rails application with JIT compiler.
Cool.
So it sounds like you're getting more and more into what'll be easy for a regular Rails developer, a regular Ruby developer just to use it as it gets more experience. So inlining the methods and working on a JIT compiler, are there any other major efforts that are being made to speed up Ruby 3.0?
Other efforts are not only inlining method. I made many efforts to inline some functions in VM instructions because many VM instructions can be compiled down to some usual C function calls. So it's very easy to inline VM instructions, such as plus method is by default, it's just some very basic plus instruction, not like actual Ruby method call if it's not redefined. So things like that can be very optimized without method inlining.
It sounds like some of the the way that Rails uses metaprogramming and some of the ways that Rails organizes itself might make it a little bit harder to optimize, at least for now. Working on.
Yeah, if some of the optimized methods are redefined, such basic optimization can't be available. So I need to work on the method inlining.
Sounds like a tough problem.
Yeah.
I'm all for a faster interpreter. I think that'd be great. But, I think that most applications that people feel that are slow, a lot of times it's usually some inefficiencies in their code. I refactored something the other day, and, the Fibonacci sequence is a great example, a microcosm of the issue I was having. And the speed increase that you can do just with refactoring code using memoization, just different techniques that are built into Ruby and concepts that you can apply to your Ruby functions, you can get massive speed increases out of just reworking some things.
It's really interesting too. A lot of the culture at Ruby is that a lot of Ruby developers don't think that way, but it's absolutely true. By thinking about optimization in our code as well, we can share some of that burden and enjoy that as well.
I want to solve the problem that is not essentially a problem by the developer. And you may know that the fact that while loop is faster than each loop, enumerable each. So, but we as a developer want to write each loop instead of while loop. So I want to solve such unnecessary problem by implementing the JIT compiler.
I like that. I also like the way that Matt's put out there the 3x3 challenge to have a three times increase for Ruby 3.0. I love how that form of leadership of showing us what we think we can accomplish, and then letting us try different things to see what to do. I like how that seems to be creative and getting you involved in lots of different ways.
Takashi, I'm not going to claim to be like a deep knowledge guy of the Ruby internals and how that works, but I'm watching this and I'm looking at your face and I'm imagining you as this race car driver. This engineer of a race car, where you seem like you thrive for just a tiny little microsecond speed faster. And I could see you as this, race car engineer who's just tweaking this screw here and tweaking this thing over here, and just every little tiny bit of speed that you increase makes it so that it's a huge win. Is that how you look at, for example, you've worked on the Haml library, of course you're on ERB. Thank you for that. We love ERB. We don't like Haml, but we love ERB.
I like Haml. I like Haml a lot.
Is that how you see what you do? Like every tiny little microsecond that you get faster, it's just a huge win.
Actually, I don't think ERB or Haml performance optimization are good or beneficial for total laser application performance. I rather think there are some very big bottlenecks in Ruby interpreter itself. So, at least Ruby's method call is very slow compared to some C function call. And I believe I can solve such problem by implementing JIT Compiler. So I'm actually tackling the Ruby's big bottleneck, which is some hidden for now, to solve the real world problems rather than just improving milliseconds or very small seconds for some race car, you said?
Yeah. So you'd like to have a broad-based improvements.
Yeah.
So I'm not an expert in the Ruby internals either, but I'm thinking about just what little I know and implementing a JIT compiler and looking through some of the notes as I've seen progress. It doesn't seem like that's an easy thing to implement. How long have you been working on this compiler?
I firstly work on the JIT compiler using the LLVM. It took about 3 months, but actually current JIT compiler for Ruby 2.6 is different from that. And I started work on the current JIT compiler on the September, and it took about 1 month to implement the first version of current Ruby 2.6 JIT compiler. That's because I experienced the very similar JIT compiler implementation in LLVM version. So I think the initial version implementation took about 4 months to implement that. And after that, it took so much time to resolve the race condition or some seg faults or dead logs or many other bugs. So actually, it took a year to come here.
Wow. So now the LLVM was the first version, and then do I understand correctly the current version of the JIT compiler is a registered transfer language? Is that mutually exclusive, where it's just the registered transfer language? Is that the main push on the JIT compiler, or do I understand that correctly?
LLVM is registered transfer language based, kind of, and but Ruby's instructions are stack based. So I needed to compile or translate them, but actually I needed to do very similar tasks to compile stack based instructions to LLVM IL or C code which is adapted in the Ruby 2.6. So they are using very similar code, and I could use many of the outcome in the LLVM version.
Okay, so LLVM is where you're focusing, and now I don't know what does LLVM stand for?
It was originally a low-level virtual machine, but it does not mean something right now.
It sounds like it keeps evolving as you've handled race conditions and other issues you've been working on.
So you are mentioning my current task for JIT compiler?
Yes.
Yeah. I'm currently working on the JIT compiler for improving the portability or performance. Portability has very severe issues like supporting Windows or many other platforms that doesn't have GCC or Clang. Currently, JIT compiler only works on with the JIT GCC or Clang, so it has portability issues, and I want to solve those problems to at least let JIT compiler work on the Windows.
But we really don't care about Windows, do we?
Yeah.
You want Ruby, get a Linux box or Mac.
Yeah, actually, I'm using Linux or Mac, but Windows is tier 1 support of Ruby. And I know there are many people using Windows.
Yeah.
So lots of improvements in the compiler, but it sounds like with big data and things that you're also working a lot on concurrency. Do you want to talk about concurrency and type systems?
I definitely want the concurrency for Ruby because I sometimes needed to use Java instead of Ruby for some performance-intensive application. But of course, I want to use Ruby if I can use it for a specific purpose. And so I'm very interested in the Koichi's current work. I know it will be published in the RubyConf Taiwan at first, I think. He is going to show the initial version of his concurrency model, which is originally called Guild. So I'm very looking forward to seeing the first version of it. So
concurrency with Guild, how do they handle that, or what's the big idea, or an easy way to understand how that's being run?
First of all, Koichi doesn't like thread at all, so it's not like thread, but rather the guild does not share. Basically, it does not share anything, and it's rather copy or moves the responsibility of object, but there is no public implementation that is available for us. So actually, we can say nothing for that, and we just need to wait for the Koichi.
Okay. So what do you do now with, so it sounded like you were doing a lot of big data work with Ruby right now. Is that right? Or is it mostly a mix, or how do you solve it while you're waiting for Guild?
Actually, sometimes I try to use Ruby's thread for concurrent processing because even without guild, we can parallelize the I/O processing. But anyway, we need to wait for CPU processing with CRuby implementation. So in that case, if I have some CPU intensive processing as well, I just switch to Java for now.
Okay. Yeah, I tend to have a hard time coordinating, at least in Ruby, threads and some of these things. And like you said, if CPU is getting busy, then we're kind of maxed out anyway.
Yeah. Do you like to type or write types?
Yeah, tell us about types.
I actually don't work on the type system at all, but I sometimes write types in my Ruby code. No. I just write the comment of the Ruby types, like in Yard. I probably Yard format in some at param string something, and so I sometimes like to write types to make sure what would come to the place, what values come to the place. So I like to read the types in code to know what would come to the place.
It sounds like a cardinal sin in Ruby to have to introduce types, but it sounds like by introducing types, I don't mind types personally, but so what's the what are some of the outcomes that you're getting as you're using that?
I think it's good for readability, and if it's introduced for some type checking, it would automatically ensure that type annotation is correct. Sometimes I forget to maintain the type comment I write, so it's good to automatically maintain the type annotation written in the Ruby code.
Okay, so take some annotation, and then you can do some type checking, and then how do you actually automate the updates? Do you just do that on your own? You find a way to keep that updated, or is there a gem or a tool you use for that?
I heard that Yusuke Endo, one of the Ruby committer in Cookpad, is working on some experimental library that generates the type by profiling types. Like when you run some RSpec or Minitest, you can know what values would come to the place or method. So you can profile the method by using the trace point or some profile functions. So by that method, you can automatically detect the type that would come to the methods.
Okay. So I know that for me, at least, I mean, I started writing code in C, and I had a lot of experiences with Java and other languages before I found Ruby. And I loved not having to have types because I could focus on business logic. So it sounds like it would be an optional thing once your business logic is ready. If you add types, you can have a little more safety in your code and a little more readability of what you intended to do with your code. Is that fair to say that it's an optional thing you can add as you improve your code base?
Yeah, I think it should be optional because I sometimes feel tired to write many types. So I think it should be optional because it's important to have some interface, but for some private methods, I think it's less important to annotate types because it's very easy to understand what would come to the private methods. But for public methods, it's hard to understand the interface because I need to grep or search some methods traces that calls the method.
Yeah, it gets a little bit difficult to reason about public methods, especially because if sometimes I like to get the domain logic figured out and figure out what it's supposed to do, and then by then I'm being asked to get on to the next task. And so trying to figure out all the ways people might use my code in the future is usually a luxury I don't have. But private methods, that makes a lot of sense, because you'll build a class that has what you need internally, and that can stay very clean, and I like that.
Yeah. And at the feature level, Matt's don't like to write types, probably it must be some optional feature.
Yeah, I know some people who would not want to do that at all. However, for me, the type system is such a thing where people who go to type systems wish that they were off of the type system, and the people who are off the type systems miss the value that the type system brings. So it's a grass is greener on the other side conundrum there. However, an optional path for type systems would be wonderful. I know I think that's kind of how Elixir does it. That's how Elm does it. I believe they allow you to specify that optionally. So yeah, that would be wonderful. I do have a question for you, as one of the guys really excited for the concurrency aspects of Ruby 3. Do you have any idea on a release date for version 3?
Version 3 is, I can say JIT will be available in 2.6, but others, I know I can remember some other people's ideas on it, but at least it's not 2.6. At least it's not next Christmas. Probably it's about after 2 or 3 years, I think. But it's just my wild guess. It depends on the Koichi or some other Ruby committers' time.
I have a stupid question, or it might be a very brilliant one. I'm not sure yet. So depending on how you answer it. So moving to a more optional type system, would that open up the possibilities of having a native compiler for Ruby, so that we can actually compile the scripts or whatever functions we have into a low-level executable?
So you are expecting to have something like MLB or
Okra, or something where you can actually compile down the function and then get a runtime executable.
It needs to have some compiler, some ahead of time compiler, and it's essentially different from JIT Compiler, because JIT Compiler aims to improve the performance by utilizing the cache which is available on runtime. So it needs to have some different purposed compiler that can generate function that has very limited runtime dependency. I describe the details a bit. Current JIT compiler depends on the VM availability, even if it can execute native code, because sometimes we does speculation for optimization, like inlining functions. Inlining methods that can be fallback to the bytecode execution. So at least the native code should be able to execute bytecode by VM. So it's kind of complex to achieve such binary or some single binary executable. So I think it will have another difficulty to achieve such goal, in addition to achieve performance by JIT compiler.
Yeah.
When you start a new project, typically you need things like a domain name, hosting, things like that. When I choose hosting, I pick mine for the options it gives. I like to know what I'm getting and set things up just how I like them. This is why, for your projects, you should check out Linode. Linode servers feature native SSD storage, a 40 gigabyte network, and Intel E5 processors. That's all the power you need to run VMs under full control, or Docker containers, who doesn't love that, encrypted disks, and VPNs. Plus, they have 10 data centers across the world and add-ons like backups, Node Balancer, and Longview to help you control your server costs. They also offer block storage for your static files, and you can get started with a $20 credit if you use the code RubyRogues2018. That credit is good for 4 months on their 1 gigabyte server. That's a lot of time to try them out and see if they're the right fit for you. That code again is RubyRogues2018. Also, if you're interested in working for Linode, they're hiring. Head to linode.com/careers to see their available positions.
So have you played around with the Crystal language much to kind of see what they're doing with the compiled Ruby and just some of the speed that Crystal runs at?
I've never worked on the Crystal language. Could you explain some benefits in it?
Yeah, so it's a type system language that you can write your scripts, which very closely resembles the Ruby language, but it is not Ruby. It's different.
Mm-hmm.
But they tried to make it as close to Ruby as possible while being a type-safe system. And you can compile it down into a runtime executable. So the speed differences aren't astronomical like it would be with a compiled C program and a Ruby script, but it is still of some magnitudes faster.
Mm.
It's interesting. I've used Crystal as well. It requires, well, that whole type, the discipline to build a typed system, and there's some things you can and can't do. And it sounds like from your description of having some guarantees on long running dependencies, you really can't do that the way we philosophically handle things in Ruby. You know, that we allow a lot of metaprogramming and a lot of flexibility. And so a JIT compiler sounds like it's just a fundamentally or ideologically opposite approach to the way Crystal is solving it, as far as I understand it, that getting a compiler to work just in time and speeding that up and making that work well with the flexibility rather than constraining the Crystal. Is that fair? Am I understanding both concepts well, or I'm trying to summarize everybody's ideas, maybe poorly?
Yeah, I guess constraining the features or some dynamic Ruby features would be very beneficial for improving the performance. I saw many features that blocks many optimization in Ruby. So I wish I could use many optimization if Ruby doesn't have many dynamic features. So it's very different things. Ruby's JIT compiler wants to improve the performance without dropping or removing the dynamic features. So yeah, it's very difficult problem.
Yeah.
Well, and it's interesting too, because a lot of the optimization we talk about, is in the machine or in the output of the code, but a lot of it, the real pipeline involves the people building it too. And so being able to say, well, I need to be able to understand the domain I'm working in, all the rels, metaprogramming, all the easy ways to understand how to work with things. It reduces our need for templated code and for a lot of structures that are easy just to build our intention. So I find that really an interesting thing is that, the overall business value of using Ruby really is in the whole pipeline involving the people, the development, the deployment, and the runtime. So it's fair to say that there are different problems that they're trying to solve, which I like.
Yeah, productivity and performance is trade-offs in it.
Yeah.
So with using the JIT compiler, is there an increase in memory usage as well?
Yeah, it increases memory. Of course, it needs to increase the memory usage, but it's very limited compared to JRV or some JVM-based implementations. Like with OptCarrot, it increases the memory usage about 10 or 20% compared to the only just VM execution, but it improves the performance much more. Yeah.
Yeah, you can always buy more hardware. You can't buy more time. So
Yeah. It uses much more memory in a very small script, but in real world applications, the memory increase would be very limited compared to the original one.
Mm-hmm.
And also, I can say that memory footprint for compiling methods with GCC is smaller than one for LLVM. LLVM uses much more memory, but it's not so extremely large compared to some JRV or some Java-based ones.
Nice.
So do you get to work with Mats? Do you ever like meet up with Mats for lunch, or say, "Hey, dude, let's go hang out"?
I need to share that in Japan, in Tokyo especially, we have Ruby developers meetup once a month, and I can meet many Ruby core committers living in Japan, and in all meetings, Mats attend that meeting by Skype or something. So I can talk to him in that meeting if I attend to that.
Very cool.
Nice.
I met him once at a conference.
Yeah.
He is one hip dude.
I've met him once at a conference as well. It's kind of a nice experience, isn't it?
So Takashi, when people, or at least outside of Japan, think of Ruby, they usually fall right to Ruby on Rails internet websites. What are some things that you do with Ruby that's outside of the web domain?
I can think of one thing, which is middleware named Fluentd. Do you know Fluentd? It's a log collector. I typed that. It's a log collector which is also used for some cloud services like AWS or GCP. And it's middleware written with Ruby. And so it's good for improving. It's good to improve the performance of such middleware because it will be used under the very high workload. So sometimes Ruby can be used for such very large scale application.
Cool.
So it works as middleware. What is it about Ruby that makes it great? What makes that a great fit for that?
Yeah, the great point of using Ruby for Fluentd is that it can be easily extended by writing a plugin using Ruby. So as Ruby is good for productivity, we can easily extend the middleware by writing Rubies. So there are so many plugins of Fluentd written in Ruby, and if we use Java for the same thing, it would be harder to write plugins. So I think it's the good point of Ruby for using the middleware.
Interesting, yeah, because it's so dynamic and easy to plug in something.
Yep.
And it sounds like with the middleware, you can build quite an interesting data pipeline. Anything you need to push, any kind of transforms you need to make, or connect with different types of environments. Wow, That sounds actually very interesting. I don't know why it's never crossed my radar until today. I'll be checking that out.
Actually, currently, we would be able to use mRuby for such purpose because mRuby is for embedding Ruby for some softwares. We can software programs embed it for software. And but if we do so, if we do embedding MLB to some C or non-Ruby languages, it's very hard to maintain the middleware itself. So I think it's still beneficial to use Ruby for implementing middleware itself.
Yeah, I know in my work, we do a lot of data transforms over large pipes, and trying to understand how that comes together and having a fluid understanding of that every step is done simply and clearly, and that it's a reliable pipeline. That's not an easy problem. I've been up a lot of nights in the last few years thinking through these kinds of problems when things go wrong on that kind of thing. So that sounds very interesting to have a dynamic way to plug in tools and integrate a full solution.
Yeah.
Nice. Now, so I know you work a lot with big data and you build microservices. Are you using FluentD with your microservices, or are you doing that more in a more typical Ruby fashion, or how do you use microservices?
FluentD is used for all services to collect logs by any application. So it's not kind of related to the microservices, but rather I create microservices to split some monorays into the some separated applications, which correspond to the some teams of the company to improve the productivity to develop those components separately. If we share the same application across the teams, it would be very hard or challenging to keep the productivity.
The way I explain it to my team is if I have a monolith, it's this big vertical thing, and it does a lot of complicated things that are hard to understand. But that I usually, when I talk to my team, I wave my hands a lot to see if they can understand what I think is important. And I explain that, well, we go from a vertical monolith and we spread it out horizontally so that it's replayable and that there are events going across the services, and that it's transparent enough that I know if it's working, and I know if there's a problem, I can replay it and get it to work well. Is that how you think about microservices, or do you think about it differently? But I seem to be like the evangelist, always talking about turning things into a very easy to understand pipeline instead of just a big monolith. But anyway, how do you think about those kinds of things?
Yeah, I agree with it because simplifying the responsibility of components would make it easier to maintain. So I also agree that idea too.
It's just there's a limit to human capacity. I think that we just need to respect that. I can remember 10 things if I'm having an incredible day, 3 things on a normal day, and if my monolith is doing 500 things, there's just no way I can really understand it. And then I have to trust unit tests I wrote maybe a year or two ago that maybe things have changed, or maybe I'm not noticing everything. So I have to find a way to architect my system so that I can understand what it's doing. I'm the bottleneck. So I have to architect so that I'm not the bottleneck.
Human can't understand or do everything. So microservices are a good abstraction for any engineers.
I think so, yeah. Well, it's interesting too, because we get deep into a problem and we have a lot of fun with it, and it's all in our head. But I'll bet almost every time within a week after we've solved that problem, we don't remember that. And so if we can't get back to it easily, it's a real struggle.
Yeah. Well, I think, and I'm sorry for this. Well, actually, I'm not. I like it. I really like and follow DHH's, the master big monolith, because if you can structure your code, if it has a logical flow to it, where everything, is in its own place, then, following it through and debugging or going back and rewriting, refactoring some parts isn't that big of a deal. However, if I'm writing a lot of code within this monolith that's going to be reused within other applications, then it should be extracted into a microservice, or like Microsoft's DLL files. They're just, extractions of a function or something that can then be used by other applications or shared between different apps. So I think breaking out your application just to break it out may not be the right, personally speaking, may not be the right way, unless if it is going to be something that's globally shared.
So it sounds like you agree on the idea that it needs to be understood and correct, and that you don't, and that's a big problem. But you don't like to break it out into other services unless it's shareable.
Yeah, otherwise, why break it out? There has to be an actual reason to break it out into a microservice, in my opinion. If it's something where I know that this one service or resource, function, whatever, is going to be extremely CPU intensive, but I don't want to hurt my web requests or my other users' requests that are coming in while this real heavy thing is going on, then that's a good enough reason to extract it. So it doesn't have to just be globally shared, but there has to be a purpose or reason to extract it, not just for the sake of extracting it. And then that way, that service I can throw on a whole nother machine, beefier CPUs, whatever, and then have it communicate back to the main application with whatever way it needs to. And then it can have all the resources while I have my own little farm or tier of web servers handling the bulk of the requests.
I like that. I was going to push back a little bit because shareability is definitely a good reason to break it out, but the reasons for resources is well, but it sounds like you agree that if there's a good reason to break it out. The other thing I would say too is that if it's understandable, however you architect your system, as long as it's understandable, you know what each step is. To me, the principles are: is it replayable? Can I handle duplications? If there's duplicate data, can I handle that well? So I can handle replayability and duplications well, and that it's transparent. So as long as I have those, and then however I achieve that, then that makes a lot of sense, whether it's a microservice or maybe service objects or maybe other things that we could use to make sure that it's a good fit. So it sounds like we agree. We need to be wise when we break things out, but that we do need to have the human limitations somehow as part of the conversation.
So this is just an example where on a Ruby on Rails application, I started seeing that my background jobs or my background workers started to consume a lot of memory, where they were just doing some really intensive calculations. And we saw that we also had a lot of concurrent requests coming in from users. So my servers, I had behind a load balancer, but each one of the web servers were starting to struggle to handle the user traffic because the background job was consuming so much memory that the server wasn't able to spin up new workers to handle the web requests. So I extracted out, just moved the Sidekick processes over to a separate server, so it was able to get the resources it needed, and the web servers were able to handle the requests quickly. So it doesn't have to be your own code. It could be just different different components of your application, whether it's Action Cable, Sidekick, or whatever other add-on that you've had with your application.
I like that. I've also had that experience with databases where sometimes I get intensive processes running in the database and that it gets in the way of operations. And so, replicating the database and doing some things in other areas, especially, reporting or other things, those are easy to break out. So getting a sense of the whole system, how it's, can it run?
Yeah, I experienced a similar thing for some intensive things. Our previous user application has some logging interface that has so many hot requests, but it's not good for processing by Ruby. So we extracted the login endpoint to another service written in Go language. So as currently Go language is much faster than Ruby, it's good to handle so many requests.
Yeah.
I've heard that a lot. People will, if you have the architecture where you can break things out, you can go to Go or other languages to do little things here and there if you need to, or big things if that's the case.
Yeah. So microservice is just one choice of architecture to change architecture. Yeah.
So it sounds like in general we're talking about. We're making the core Ruby faster. We're getting concurrent so that we can run more. We're building it in microservices when we need to, handling it with types so that it's understandable and more clean. And it sounds like a lot of good ideas for architecting fast, reliable systems.
Yep. Next is serverless.
I love that for hype, for marketing. That's brilliant. And then the engineer part of me just cringes every time I hear serverless. Like, of course there's a server. You just aren't thinking about it.
Yeah.
But that's a brilliant way to hype things.
And I'm very sad that AWS Lambda does not support Ruby for it. And our colleagues using Python because Ruby is not supported by Lambda. So I'm very sad.
Do you think that they're going to change it? Like Amazon will wake up and be like, oh, people actually do use Ruby. Maybe we should support it on Lambda.
I hope they support that later, but at least recently they supported Go language, which is newer than Ruby. So I think it's a little difficult.
Because, honestly, there's really no difference in supporting Ruby versus supporting Python, is there?
Yeah.
They're both scripting languages at their core, You just feed it a file, it runs its thing. Why won't you support it?
Yeah, I actually don't understand why they don't support that. Yeah.
I think it's tied closer to the dependencies in Python. Python's tighter, and with Python and things, you can compile it down into fast tools. So it might just be the structure of Python is I don't know if I want to call it simpler, but it just might. I don't want to champion Python on a Ruby podcast, but there are I think some things that make it a little bit easier to split it out, especially when we're dealing with dynamic use of Ruby. But that might not be fair. That might not be a good enough reason to keep it out of Lambda.
Yeah, if that's some of their concerns, all they have to say is like, look, if you want Ruby on Lambda, that's cool. We'll support it, but you can't do all this crazy meta programming crap. You can just have a method, give it some parameters, we'll give you an output. Is it really that hard? Come on now.
It might not be.
So, I got an opinion about that if you haven't noticed.
I have strong opinions in certain areas, but I've kind of come to embrace this polyglot life that we live. I love Ruby, and I use Ruby when I can, but boy, I tend to use in a given week 5-6 different languages. So I don't know if that's typical, but. So I guess I don't have that strong of an opinion about Ruby and Lambda, but
all right.
Well, great. Well, should we move on to picks?
Yeah, I think so. Well, Takashi, if people want to get a hold of you, where can they go?
Hey, when it comes to health, you probably have some of the same disqualifications that I do. You sit all day, you run a busy life, and when you do make it to the gym, the only thing you're really qualified to do is turn the treadmill on. I was an athlete in high school, and so I could have thrown swimming in the mix, but that was about it. And I didn't really know what to do when I decided that I needed to get my health under control, especially since I have type 2 diabetes and I want to be around for my kids. So I contacted my friend JC over at DevLifts, and DevLifts, they did me a huge favor. Sure, it's a paid service, but what they did is they gave me a workout program. They also gave me some eating guidelines, and they have a Slack room where I can go and I can ask questions, and they give weekly challenges on things that I need to do differently. I really, really love it. So if you're looking for a way to get into shape, you're looking for a way to improve your health, then go check them out at devlifts.io. That's DEVLIFTS.io.
My picks for you guys is the first one is MD2 key gem. It's my Ruby gem that can convert Markdown to Keynote file. So please try that if you give us some presentation using Keynote.
Nice. So a keynote from Ruby. I've done that a lot of times. The 2 o'clock in the morning before a presentation of, okay, now I've got to get my slides together. So that's your pick. And then how can we get a hold of you to find you online or follow what you're doing?
You can see the my GitHub repository to see the GIF animation that demonstrates how it works. So please you see that.
Okay. And I'll just read out your handle there. It's Kokubun, but the O is a 0. So K0K.
Yeah. 0. Because all version of Kokubun is very popular in many services. Yeah.
Kokubun with the 0.
Yeah.
Because it's the beginning. It's the 0G, the first generation, right? 0G.
Yeah.
Great. Dave, how about you? Do you have any picks?
Yeah. I haven't been on the show for a few weeks. And so I had like this whole list of picks like picked out and stuff, but I forgot them all. So I'll pick my most recent pick that I have. I just got a new car. I've, had the same car for the past 10, 12 years. No problems with it, but when it rains, it pours. So it ended up started needing thousands and thousands of dollars of maintenance and work and stuff on it. So it was beyond what the car's value was, fivefold. So I just picked up a 2018 Honda Civic Si. It is a fun car. I love it.
Beautiful. And Eric, how about you? Do you have any picks for us today?
Yeah, I got a couple. The first one is a book that I finished reading, I think a couple of weeks ago or last week. It's by Dan Brown, the creator of Da Vinci Code, and the book is called Origin. It's a fantastic book that travels into the world of artificial intelligence and the origin of man. So it's a fun book to read. The other one I have is an app that I use on my Mac and on my phone, which is called Tunnel Bear. Now I use Tunnel Bear to funnel any of my network traffic through a proxy that has no logging or anything whenever I'm out. So, and it automatically turns on. It's got a fantastic UI and interface. But every time I go to Starbucks, it connects to Starbucks on that Google thing, and then it immediately funnels through Tunnel Bear. So all my traffic is hidden. So anyway, great products.
I love that. I tend to open up a VPN tunnel all the time when I'm out and about, just because I'm nervous of what's going on.
I have a gigabit connection at home, so whenever I'm out and about, I have a pfSense server that I built in my basement, and it acts as my VPN server. So I just VPN into my home, so all the traffic from wherever I'm at to my home is encrypted, and then I have whatever security protocol set up at home that then safely sends out my traffic. So
nice.
I'm a bit of a nerd, though.
Perfect. Well, Takashi, do you have any other picks that you'd like to share with our listeners? Anything else that you find interesting or fun?
I have other library I built, which is called Mitamae. It's a library like Chef, but it's built with mRuby, so it can be executed without Ruby interpreter. It's just a single binary to evaluate the chef-like recipes. So you can provision your server without Ruby interpreter, but you can still use the Ruby language to provision your servers.
Wow, that's amazing. I didn't realize that it was so portable. That's amazing.
Yep.
Awesome. Yeah. Well, My pick today, I got to tell you, I'm in love again, and it's Joan Didion, an author. Oh my goodness! And so I've read a few of her books recently. She has currently a documentary on Netflix about her life. And the thing that is amazing to me as a software developer, as an engineer, as a human, I love her mind. So in 1970, she went down to the South and took a few notes. And in 2000, goodness, 5 or 10 or 15, she published a book from that journal. And it's amazing. And it's just as clear about the South and the West that, as if she had written it just barely, if she'd just gone down there. And so anyway, her mind is amazing. So she wrote A Year of Magical Thinking. She's got this Netflix documentary. She wrote South and West. She wrote a lot of other books. Amazing thinker and incredible. And one of the things I love about it is just that she's realistic and clear in the present moment with everything she does. And so it seems like that's a good thing for anybody writing software to be around people like that, to see how beautiful our minds can be. So that's my pick today, Joan Didion. Amazing, amazing person. All right. Well, let's wrap this up. Thank you, everybody, for listening. Have a great day.
Yep. Talk to y'all later.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.